Article 250.110 of the National Electrical Code addresses grounding conductor continuity and attachment. Section 250.110b focuses on equipment grounding conductor continuity. It mandates that the equipment grounding conductor must be continuous between any combination of the following points. Firstly, the grounding electrode system. Secondly, the equipment grounding conductor terminals of the devices or enclosures. Thirdly, the grounded service conductor or its enclosure. Importantly, Section 250.110b states that a grounding conductor must remain attached even when a raceway or cable is disconnected or removed. This requirement ensures that a fault current can always find a path back to the source, tripping the circuit breaker and preventing electrical shock hazards. While the code doesn't explicitly dictate a minimum length of 6 inches for the grounding conductor before it reaches the ground screw on a steel box, the principle of maintaining continuity during raceway disconnection justifies this practice. The rationale behind the 6-inch length is to provide enough slack in the grounding conductor. This slack allows the conductor to remain connected to the box even if the conduit or cable is damaged or completely detached. Without sufficient length, the grounding conductor might be pulled out of the ground screw upon disconnection of the raceway, effectively breaking the grounding path. Consider a scenario where an electrical metallic tubing or EMT conduit connected to a steel box is accidentally struck and severed. If the grounding conductor inside the box is too short, the force of the conduit being pulled away could also dislodge the grounding conductor from its termination point in the box. With a 6-inch tail, the conductor has enough play to withstand this pulling force and maintain its connection. Similarly, if a metallic-clad RMC cable is damaged near the point where it enters the box, a short grounding conductor could be compromised. The extra length provides a safety buffer against such occurrences. Grounding is a critical safety measure in electrical systems. Its primary purpose is to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices, such as circuit breakers or fuses, which interrupt the flow of electricity during a fault condition. Without proper grounding, a fault current might find alternative, unintended paths to ground, such as through a person touching a live conductor or a metallic enclosure. This can result in severe electrical shock or electrocution. The equipment grounding conductor, or EG, is the conductor used to connect the non-current carrying metal parts of equipment, raceways, and enclosures to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metallic water pipe, or a concrete-encased electrode. The EGC provides a path for fault current to flow back to the source, allowing the overcurrent protective device to trip and to energize the circuit. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. National Electrical Code Table 250.122 provides the minimum size requirements for equipment grounding conductors based on the ampere rating of the overcurrent device. For example, if a circuit is protected by a 20 amp circuit breaker, the minimum size equipment grounding conductor required is number 12 American wire gauge, or AUG, copper. If the circuit is protected by a 60 amp circuit breaker, the minimum size equipment grounding conductor required is number 10 AWG, copper. Proper termination of the equipment grounding conductor is crucial to ensure its effectiveness. The grounding conductor must be securely connected to the metal box using a listed grounding screw or other approved grounding device. The connection must be tight and corrosion resistant to provide a reliable electrical path. It's also important to avoid creating ground loops, which can occur when multiple grounding paths are present. Ground loops can introduce noise and interference into the electrical system, potentially affecting the performance of sensitive electronic equipment. To minimize the risk of ground loops, it's generally recommended to ground equipment at a single point. When working with electrical systems, always follow safe work practices and wear appropriate personal protective equipment, or PPE. This includes safety glasses, insulated gloves, and appropriate clothing. Always energize the circuit before working on it and verify that it is energized using a voltage tester. If you are not qualified to work on electrical systems, it's best to hire a licensed electrician. Improper wiring can create dangerous conditions and pose a serious safety risk. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and industry best practices. It's essential for electricians and electrical contractors to stay up to date with the latest edition of the National Electrical Code to ensure that their work complies with current safety standards. In addition to the National Electrical Code, local jurisdictions may also have their own electrical codes and regulations. These local codes may be more stringent than the National Electrical Code and must be followed. The authority having jurisdiction, or OJ, is responsible for enforcing the electrical codes and regulations in a particular area. The authority having jurisdiction may be a local building department, a fire marshal, or another government agency. Electrical inspections are typically required for new construction and renovation projects to ensure that the electrical work complies with the applicable codes and regulations. Electrical inspectors are qualified professionals who inspect electrical installations to verify that they are safe and code compliant. If an electrical inspection fails, the contractor must correct the deficiencies and schedule a re-inspection. Grounding and bonding are essential aspects of electrical safety. Proper grounding and bonding help to protect people from electrical shock hazards and to prevent damage to electrical equipment. By following the National Electrical Code and local electrical codes, electricians and electrical contractors can ensure that electrical systems are installed safely and reliably. In summary, while a specific 6-inch length for ground wires isn't explicitly mandated in the NEC, it's a sound practice derived from the code's requirement for continuous grounding even when raceways are disconnected. It provides a crucial safety margin, ensuring the ground connection remains intact during potential damage or separation, safeguarding against electrical hazards. Always prioritize safety and adhere to best practices to maintain a reliable and code-compliant electrical system.